Under the corridor that was saying, are you coming to the to the prom on Saturday? Has now switched from whatever it was displaying before to showing a page interpreting the rules of what are the instructions, what are the guidance guidelines for a gun attack wherever it is in the building. But the important thing is it knows the location of that attack. It knows its own location, so it uses those geo rules to then, and we provide all the sub capabilities for all those calculations within the unit. It uses all that geodata rules to then say not only there's a mad gunman in the refectory, but he's that way, leave the building that way through that door. Now at the other end of the corridor there could be another camera with another emergency messaging display connected to it. What's come up on that display? Well, that camera knows it's the other side of the incident. It says, whatever you do, don't go that way, leave by that door. And all those decisions are being made within each individual emergency initiator, and also it could be the fact that it's not just simple graphical displays. It could be the fact that there's some form of scenario that needs a equivalent of a public information film. Take the other horror nightmare scenario, the dirty bomb in the city. Now this is something we've not had yet, but I'm afraid it's almost an element of inevitability as to when that's going to happen somewhere in the world, unfortunately. That has its own unique problems. The people that are close to the instance, there is only one thing you can say to them: stay where you are. Although you may have already been contaminated, it's far better that we send medical people to you and we do something about it, because if you try and leave and run away, you're probably just going to run away long enough to find a corner to curl up and die in. Equally, someone who's 5 miles from the instance, on a bus, on a vehicle, that's safely outside the contamination zone, the message you want there is, this vehicle's not turning round. There's been a dirty bomb or conventional bomb or whatever in the middle of the city. You are being taken to the nearest marshalling yard at. The unit knows which is the nearest marshalling yard, because part of this now will be where the marshalling yard, what's my location, which is the nearest one, that's where this bus will take people. Then you can use that asset to go and get the people from the middle zone. At the moment they're not they're not contamination affected, but if we leave them there any longer, they're going to be. So now you've stopped people coming in, and you've released the mobile asset to actually then help the situation, and you then use that mobile asset to then get those people out. This is a wonderful, terrific return on investment. We've got a number of people now already looking at planning major projects to leverage this. Because of the nature of the technology, it is barely an incremental cost at all to the solution. So it's because of our original fundamental design goals: maximise technical innovation to meet or exceed the customer's expectation. And I think emergency messaging is a classic example that shows how we set out to achieve that. So we did start with that lofty goal. What was our mission? And I hope today I've been able to share with you both what we've done in the past to achieve that mission, what we're doing now, and what we plan into the future with the technological steps to make sure that anything that you buy, I hope our problem in 10 years' time is that whatever it is that's in 10 years' time has replaced the IP ICR. We're going, God, there's still an awful lot of those IP ICRs out there. People are still using them after 10 years as well. I hope that's the problem that we've got. So, and if that's the worst problem we've got, I think we will probably be able to say that we delivered our mission. Thank you very much for your time. I hope you found it useful. If anyone's got any questions, I'm more than happy to take questions. Well, when you get to individual PTZs, we've supported multiple types of PTZs for many years on the actual unit. So we've always been able to configure different protocols on different ports on the unit. This is really a bit of a step beyond that, where we're not talking about controlling individual PTZs, but controlling a complete infrastructure. It may well be that you've actually got a complete matrix there. Now, when we're in that environment, we tend to do that. Our primary solution that is with the picker point, whereby you've got your new control desk, your new user interface, joystick and everything, and we we use the picker point to integrate in the legacy system with the current system such that it provides the translation. So the simple answer is yes, but we can do it on two levels. We can do it on a micro level on a per channel basis, within the server, but when we get into a wider system type basis, that's when we'll leverage the VMS, the picker point, on our partnership with BBV, because obviously their experience that we've worked with them for many years now has been bridging between different protocols, converting it, and that's been a very key capability that many people throughout the industry have relied on at one time or another, that's now, that experience has now been embodied in the picker point VMS, which is one of the key components within our VMS solution. The battery backup capability on the ICR is, the ICR is a very new concept. We only actually, effectively conceived the concept itself in the discussions in January, February this year. However, the ICR is a power over Ethernet device as well, and you can already buy today power over Ethernet hubs that have optional battery backup. So there is today there is a method by which you can do it. Within a few weeks' time, we intend to launch this specialist hub, which will basically take a generic version of that and produce a targeted optimum version that will maximise the ROI and add the features like the AOE storage, and we will also be maximising that air gap, that protection of your system. Well, you can. I mean, the chip point devices were originally targeted in their initial before we bought the company as handheld media players. So I mean, the ICR is a single chip plus peripherals in there, and you could certainly run that for a significant period of time off a battery. It wouldn't be an issue. So part of the benefits of the chip height technology is it allows us to achieve a lot of the performance figures by putting a number of low power consumption, highly efficient codecs. In our high performance decoder, there's actually 16 separate chip height decoder boards, relatively small. They're only actually a bit bigger than that, and they're only running on about 2 or 3 watts each. So the whole box is still only a 50-watt box. If you do that with individual PCs to drive your barcode controller, you've got 4 or 5 200-watt PCs and a 100-watt barcode controller and everything else. So heat, cost, space, air conditioning costs in the control room by the time you get all this stacked up. So the great thing about the chip height device is that it can be very, very low power consumption. So battery operation is perfectly viable. In fact, we've had a couple of people talking to us about potential applications for body-worn cameras, stopping people ducking up traffic wardens and things like that. Anything else? Well, thank you again for your time. I appreciate it. It's in a busy show. We thank you for taking the time out, and we do hope you found it useful and informative. Thank you very much, everyone.